Hello. Today we're going to learn about the unit circle and how we can find sine and cosine with it. This will take us one step closer to see why the graphs of sine and cosine are the curves shown below. Let's get started. In our last video, we redefined the sine and cosine and tangent based off of a point, xy, and its distance away from the origin, r, as the following. We defined sine as y over r, cosine as x over r, and tangent as y over x. That enabled us to talk about the sine of an angle, even if we don't have a right triangle around. But those definitions are a little bit clunky and require us finding this distance r away from the origin. What if that distance was always 1? Then y divided by 1, well, sine would just be y, and cosine would just be x, and that would be really nice. So that's why we often talk about sine and cosine as being part of what's called a unit circle. The unit in this case is simply telling us that the radius is a 1. It's helpful in situations like this to think about a point, P, that rotates around the outside of the circle. And if you do, the coordinates of P always have an x-coordinate of cosine and a y-coordinate of sine. This greatly simplifies how we can think about sine and cosine, no longer as fractions, but as simply lengths. We can think about the sine as the y-coordinate, or the height. We can think about the cosine as a x-coordinate, or width. And we can still think about tangent as the ratio of y over x, or the slope. A good understanding of the unit circle can give you an excellent way of estimating sine, cosine, and tangent values, which is an important skill, even in the age of calculators and computers, because there's a whole lot of mistakes you can make while using technology. I hope that you will learn to estimate before you calculate using the process we show today. Let's try that with a couple examples. Suppose I wanted to know what sine of 30 was. Well, I could reach for my calculator and type it in. I want to see if I can estimate it first. Let me look at a picture. You don't have to be able to draw a really good picture to be able to do this process, by the way. Anyway, here's a unit circle, and remember the radius on a unit circle is 1, and my goal is to find sine, which is a height. And so if I look at this point and try to estimate its height, I would say it's probably about halfway up. And so I would think that the sine of 30 is probably 0.5. Now let's reach for a calculator and type that in. Suppose we type sine of 30 and hit enter. And I'll try that a moment in my real calculator here. All right, it gave me negative 0.98803162241. Does that seem right? Well, if you hadn't done this estimating trick, you'd probably just write this down and move on to the next problem and never even realize that something's wrong. What's wrong in this case is that most technology, by default, looks at angles in radians instead of degrees. And so right now, this calculator is in radian mode. If you want to switch it, it's easy enough to do. Hit mode, go about halfway down and find radian, switch it over to degrees. Now, if you do the exact same calculation, you'll get exactly 0.5. That's pretty cool. Usually my prediction is not nearly as accurate as this. Let's try this now with cosine of 170. Here's 170 degrees. It's almost 180 degrees, so just about straight across. And I'm looking now for the width. And so this width looks like it's almost a whole 1. It is important to remember that cosines are negative when you go to the left like this. And so I would estimate that cosine of 170 would be about negative 0.9, maybe even 0.99. Now I'm going to reach for my calculator and type cosine of 170. And the calculator gives me negative 0.9848. That's pretty close to our estimate. Let's try another one. Tangent of 140. Here's about 140 degrees. And I need to know what its tangent value is. Tangent is the slope of this line, and it looks like it's got a slope of pretty close to -1. And so that would be my guess, -1. Let's try typing tangent of 140 into the calculator now and see what we get. -0.839, which is pretty close to -1, considering I didn't really think about the numbers that much. How about sine of 180? Sine of 180, well, here's 180 degrees. Sine's the height. It looks like there is no height. And so I would estimate with really good confidence that sine of 180 is probably exactly 0. Let's type it in. And sine of 180 is 0. Nice. All right, your turn. Here are two pictures for cosine of 280 and tangent of 200. Why don't you try to estimate their values and then type them into a calculator. Don't worry if your estimates are different than mine, because we probably thought about it a little bit differently. But I thought the cosine looked, I don't know, about 0.2 if this is one whole. And I thought the tangent, that maybe if this was a 1 and this was 3, that it kind of looked like it had a slope of up 1 over 3. The actual values are 0.173, which isn't bad, 0.2. And a third is 0.333, which is pretty close to 0.3632. So, all right, let's imagine the path that P takes as it rotates around this circle. And while it's doing that, let's think about the range of sine and cosine and tangent. If we think about sine, it was just 0 there, and now our heights are getting more and more negative, and it reaches a most negative of -1. And then it's back to a height of 0, and it looks like it's rising to a height of 1 is the biggest it gets, and then back down to 0 again. So the range of sine is anywhere from -1 to 1. If we think about cosine, cosine starts off with 0 degrees. It starts off with a maximum value of 1, and then that width gets smaller, and now it was just at its most negative width. Now it's back to 0, and eventually that gets back to a 1. And so we would say the range of cosine is also from -1 to 1. And if we think about the slope right now is, well, a vertical line has a slope that's undefined. And right now, it's got a slope that's really steep and negative. So definitely more than -1, like a -2 or -3 or -10. In fact, right at the 91 degrees or something like that, it has a ridiculously steep slope. If we continue to watch it, now it's got pretty small values. Now it's got a slope of small positive values, and now it's reaching about its maximum value. So the range of tangent is actually a little bit more challenging because it doesn't have a defined range. It ranges everywhere from negative undefined, which isn't really a number, to positive undefined. We probably ought to say that it ranges from -infinity to positive infinity. So if we go back to a chart that we saw the other day, if we watch as the angle goes around and around in each of the different quadrants, sine of 0 starts off as a height of 0. And then as it rises through quadrant 1, it gets more and more positive until when it reaches 90 degrees, it has its biggest value of 1. As it continues to rotate around, the sine is still positive until we reach 180, when that height is exactly 0. And then it goes in through the negatives. I encourage you to imagine P as it rotates around and think your way through each of these different values of cosine and tangent. And then be sure to come back for our next video when we really start to graph all these things and produce the curves. Thanks for watching.